Hi, welcome back. So in this video, we are going to discuss June 2022, question number 3. A tractor of mass 6 tons is dragging a large block of mass 2 tons along rough horizontal ground. So we need to draw the diagram here. If the diagram is correct, then it will be easy. So we have a rough horizontal plane and then a tractor of mass 6 tons. 6 tons means it is 6,000 kg. So weight will be mg. So 6,000 g will be the weight acting downwards. So it is dragging a large block of mass 2 tons. So a large block of mass 2 tons. 2 tons means it is 2,000 kilograms. So the weight W is equals to mg. So 2,000 g will be the weight acting downwards. So now going back to the question, the cable connecting the tractor to the block is horizontal and parallel to the direction of motion. So there is a cable connecting the tractor and the block. The cable is modeled as being light and inextensible. Light and inextensible means the mass is negligible. The driving force of the tractor is 7,400 Newton. So a force of 7,400 Newton is the driving force, and the resistance to the motion of the tractor. So this is the tractor. So resistance means it will be acting opposite to the direction of motion. So the resistance is 200 Newton. The resistance of motion of the block. So this is the block here. The resistance is R Newtons, where R is constant. So resistance will be R Newton. Given that the tension in the cable is 6,000 Newton. So tension 6,000 Newton. So 6,000 Newton. Now find the value of R. So the diagram is done. If the diagram is correct, then it will be easy for us to find out the value of R. So in this case, to find the value of R, what I'm going to do is I'm going to consider the tractor first. I'm just going to consider this portion of this diagram. Just going to find out the, just going to use this second part of the diagram, which is the tractor. We know the formula F is equals to ma, and we know that there is an acceleration in this direction. So we need to find out the acceleration first of all. So I'm going to find out acceleration using the second part of this diagram, which is basically the tractor part. So the force will be 7,400 Newton, which is acting towards left. 200 Newton is the resistance acting towards left, and 6,000 Newton, that is the tension which is acting towards left. So 7,400 minus 200 minus 6,000 is the force, and mass of this tractor is 6,000, and acceleration is what we need to first find out. So 7,400 minus 6,000 is 1,400. 1,400 minus 200 is 1,200. So 1,200 is equal to 6,000 A. So therefore A will be 1,200 divided by 6,000, which is equals to 1 by 5, or can be written as 0.2 meters per second square. So we got the acceleration from the second part of the diagram, which is basically the tractor part. Now the question is to find out the value of R. So to find out the value of R, what I'm going to do is I'm going to just use another color here. So I'm going to take this portion of block, and now we are going to use the same property. We are just going to use F is equals to ma for the first part of the diagram, which is for the block. So I'll just write it over here. F is equals to ma. So now the force, we have 6,000 Newton towards right and R towards left. So 6,000 minus R is equals to mass is 2000 into acceleration. It's constant acceleration. So acceleration, we already got the value as 0.2 into 0.2. So 6000 minus r is equals to 2000 into 0.2. That will give you 400. So minus r goes to the right hand side, it becomes positive r. And 6400 goes to the other side, it becomes minus 400. So 6000 minus 400 is 5600. So the answer will be 5600 Newton will be the resistance for the block. Now we have the second part. First part is done, 5600 Newton. The second part is state how you have used the fact that the cable is modeled as being inextensible. So that's a theory part. It's a 1-mark question. So we say that the acceleration for the tractor and the block, it is just the same here. So state how you have used the fact that the cable is modeled as being inextensible. The acceleration for both the tractor and the block is the same. So same acceleration for the tractor and the block. So that's it. This was a 7-mark question. I hope you understood how to solve this. If you have any doubt, let me know through the chat box. Thank you for watching.